Hello dear students, in last lecture, illustration number 7 is completed. Thereafter, it is also less than and more than type cumulative frequency distribution. Today next start the illustration number 9. Less than type cumulative frequency distribution of weight in kg of 50% is given in the following table. Less than type cumulative frequency distribution data is given. Less than upper boundary point weight and less than type cumulative frequency distribution. So check it. In your first value is 0 and last value is total number of person 5050. After table first question, how many persons have weight less than 45 kg? Okay, less than 45 kg number of person find out. So check it. In your table, your less than 45 cumulative frequency is 30. So 30% have weight is less than 45 kg. Second question. How many persons have weight between 50 kg to 65 kg between? So less than 65 kg weight number of person is given 49 and less than 50 weight number of person is 39. So difference 11 is person including weight between 50 to 65. And last question, obtain the original frequency distribution. Means original classes finding. So write down in your first question. Is clear that clear that 30% have weight less than 45 kg. Okay, this table clearly indicate that 45 weight 30% weight is less than 45. Next, number 2. Second, how many persons have weight between 50 kg and 65 kg? So first of all, write down number of persons. Weight less than 65 kg. Weight less than 65 kg. Okay. Check it in your table. Less than 65 kg cumulative frequency is 49. Number of person is 49. And number of person weight less than 50 kg. Check in table. Less than 50 kg weight cumulative frequency is 38. 38% weight have less than 50 kg. So difference between 65 kg and 50 kg is less. So 55 to 60 kg between weight person is 11. So write down number of person. Number of person weight between 65 and 50 kg is equal to 49 minus 38. So 11% weight between 65 and 50 kg. Okay. And last question, number 3. Of the original frequency distribution. Can you write down original frequency distribution? First of all, table to it properly. 2 columns. Okay. Less than upper boundary point weight. This weight is given. First column heading write down weight in bracket kg. In second column number of person in our frequency f. So check it. Lower boundary point minimum 30, 35 and last highest is 70. So classes. First class 30 to 35 kg between weight number of person. 30 to 35 for the first class. Next class 35 to 40. Next 45 and 40 to 45. Next class 45 to 50. Next 50 to 55. Next class 55 to 60. Next 60 to 65. And last class 65 to 70. And total. Check it here. Question. Less than 30 number of person cumulative frequency 0 and less than 35 kg cumulative frequency 7. So for the first class number of persons 7 minus 0. So 7 person having weight between 30 to 35 kg. Okay, next. Less than 40. Weight number of persons 15. So 15 minus less than 35. Weight number of persons 7. So difference 8. 8 person having weight between 35 to 40 kg. Next, check it. Less than 45 weight cumulative frequency is 30. 30 minus less than 40 weight cumulative frequency is 50. So 15 persons having weight between 40 to 45 kg. Next, less than 50 weight number of person cumulative frequency is 30 minus less than 45 weight number of person is 30. 8 person having weight between 45 to 50 kg. Next, less than 55 weight number of persons is 44 and less than 50 weight number of person is 38. 44 minus 38 difference 6. So 6 persons having weight between 50 to 55 kg. Less than 60 weight number of persons 47 and less than 55 weight number of person is 44. The difference 3 persons have weight between 55 to 60. Next, less than 65 weight, number of persons is 49 minus less than 60 weight, number of persons is 47. Difference, 2 persons having weight between 60 to 65. And last, less than 70 weight, number of persons is 50 minus less than 65 weight, number of persons is 49. Difference 1 person having weight between 65 to 70 and here n is equal. It is original frequency distribution, classes and frequency. Here we have completed illustration number 9. Next, in illustration number 10. From the following, more than cumulative frequency distribution. In previous illustration, less than that data is given. Here, more than that cumulative frequency distribution is given. First question. Determine the number of persons having age 40 or more. Means more than 40 age, number of persons. So check it in your table, lower boundary point or more than 40, cumulative frequency is 70. So 70 persons having age more than 40 years. Next, second. Determine the number of persons having age less than 40. Okay, less than 40. Total number of persons is 100 and more than 40 persons 70. 100 minus 70 difference is 30%. Okay, having age less than 40. And last, determine original frequency distribution. Okay. So first write down the number of persons having age more than 40. Number of persons. Having age 40 or more. Checking table, data is 70%. Having age 40 or more. Number 2. Determine the number of persons having age less than 40. Total number of persons is 100 and more than 40 is 70. So less than 40 is difference 30%. Total frequency is 100. Total number of persons. Okay. Having age 40 or more is 70%. Write down number of persons having number of persons 40 is equal to total number of person is total frequency number of person minus having age 40 or more number of person at age 40 or more. Having age 40 or more. So the total number of person in frequency is 100 and having age 40 or more number of person is 70. So difference 30. So 30 person having age less than 40 years. Done. And number 3, original frequency distribution. Original frequency distribution. Two column right. The first column write down A. And second column number of person. The frequency F. Okay. So check it in your question. Minimum age is 25 and maximum 70. So our first class 25 to 30. Next class 30 to 35. Next 35 to 40. Next 40 to 45. Next 45 to 50. Next 50 to 55. Next 55 to 60. Next 60 to 65. And last 65 to 70. Next, number of person. Having age 25 or more, number of person here is your question 100. And having age 30 or more, number of person is 96. So difference find out. 100 minus 96. 4 person having age between 25 to 30. Next, more than 30 or more age, number of person 96 minus having age 35 or more is 87. Difference find out. 9 person having age between 30 to 35 age. Next 87 minus having age 40 or more is given to 70%. So 87 minus 70. 70. So 17 person having age between 35 to 48. Okay, 40 or more, number of persons 70 minus. Having age 45 or more, number of persons is 45. So difference 25 persons having age between 40 to 45 years. Next 45 25 minus having age 50 or more, number of persons 25. So 45 minus 25, difference is 20. So 20 person having age between 45 to 50. Next, 25 minus 55 or more age, number of person is 40. 25 minus 40, 11 person having age between 50 to 55. More than 55, the number of person is 40 minus 60 or more age, number of person is given to 6. So difference, 8 person having age between 55 to 60 years. Next, 60 or more age, 6 minus more than 65, 65 or more age, number of person is 1. So difference is 5. 5 person having age between 60 to 65. The last 1 minus 70 or more age, number of person is 0. One person having age between 65 to 70, age between here and number of person is 100. Okay, this is original frequency distribution. Here completed demonstration number 10. Information regarding the age of 250 drivers of a transport company is as follows. Okay, any transport company related 250 drivers related information is given. Ages. Okay, obtain continuous frequency distribution of equal class length from it. Underline continuous frequency distribution from equal class length from it. Equal class. Here mid value of age of driver. Mid value is given. The second number of driver frequencies. Mid value is frequency. So lower boundary and upper boundary. Okay, formula. Lower boundary point and upper boundary point. Lower boundary point is equal to mid value minus 1 by 2 into class length. And upper boundary point is equal to mid value plus 1 by 2 into class length. So first of all, any single one class, lower boundary point and upper boundary point. But check it, here each and every mid value between difference is 5. So 2 consecutive mid value difference is 5. Means our class length is also 5. So write down. So difference between two successive mid value. Difference between two successive mid value is 5. So class length in bracket C is equal to 5. Okay. Now next, lower limit find out for the any class, the first class, lower limit of the first class. Lower limit of the first class. Okay, lower limit formula, mid value minus 1 by 2 into plus 9. Minus 1 by 2 into plus 9. C. Okay, mid value for the first class is given to 22.5 for the first mid value. Minus 1 by 2 and class length C consider by 5. 22.5 minus 5 is the 5 by 2 2.5. So lower limit of the first class is 2020 is also called by lower boundary point. Next, upper limit of the first class find out. Formula for upper boundary point or upper limit, mid value plus 1 by mid plus length plus 1 by 2 into C. So mid value for the first class, first A of the driver 22.5 plus 1 by 2 class length is 5. 1 by 2 into 5 is 2.5. Now make step. 22.5 plus 2.5. 25. So lower limit of the first class is 20 and upper limit of the first class is 25. So our first class, okay? The first class is 20 to 25. Therefore, first class is 20 to 25. Done. So now next, 2 column right. First column write down age of driver. Age of driver. And second, number of driver. This is our frequency F. So equal class length 5. So first value, mid value is 22.5 and the last is 47.5. So our first class is 20 to 25. Next class 25 to 30. Next 30 to 35. Next 35 to 40. Next 40 to 45. And last class 45 to 50. And after total. So last mid value is 47.5 including 45 to 50 degree. Number of drivers, frequency as it is right now, no changes. 25, 30, 50. 25, 30, 50. 80, 50, 50. 80, 50, 50. N is equal to total number of driver is 250. We have completed for the illustration number 11. information regarding the number of errors per page in a book of 500 pages is a 500 pages number of error related information is given. Find the inclusive frequency distribution from it. Underline inclusive means any given that of class upper limit and succeeding class lower limit, next class lower limit, both are different. It is called inclusive frequency distribution. Here mid value and number of pages is given. First of all, the class of refined distribution, lower limit and upper limit means exclusive classes, and then after convert to inclusive. So exclusive convert to inclusive. Okay, inclusive convert to exclusive, so already 0.5 less and 0.5 add. Then same rules apply. Exclusive convert to inclusive means lower limit 0.5 less and upper limit 0.5 add. So first of all, find lower limit of the first class. Lower limit of the first class. Formula: mid value minus 1 by 2 into class limit. Okay. Here difference between two successive mid value is 2. So our class limit is also 2. In first sentence write down. Okay. The difference between two successive mid value is 2. Therefore, class length C is equal to 2. For the first class, mid value is given to 0.5 minus 1 by 2 into class length is also 2. 2 to cut, 0.5 minus 1. Answer is minus 0.5. Okay. Next, find out upper limit of the first class. Simple. Mid value plus 1 by 2 into class length. Mid value for first class is 0.5 plus 1 by 2 into class length is also 0.5 plus 1 1.5. So therefore, for the first class, minus 0.5 to 1.5. Okay, this is exclusive classes. Generally, inclusive classes convert to exclusive. Inclusive convert to exclusive. Lower limit 0.5 less and upper limit 0.5. Your rules is reverse. Why? So here exclusive classes is given, convert to exclusive means lower limit 0.5 add and upper limit 0.5 less. Clear? Generally inclusive convert to exclusive, lower limit 0.5 less, upper limit 0.5. But here inverse means lower limit 0.5 add and upper limit 0.5 less. So first of all, write exclusive classes, exclusive frequency distribution. Exclusive frequency distribution. Okay. So exclusive frequency distribution is the number of error per page. Two column right. First heading right now, number of error per page. Number of error per page and number of pages. Second column heading. Number of pages. Our first class minus 0.5 to 1.5 and here last value mid value is 8.5 equidistant. Our first class minus 0.5 to 1.5. Next 1.5 to 3.5. Class name 2 at 1.5 plus 2 3.5. 3.5 plus 2 5.5. 5.5 plus 2 7.5 and 7.5 plus 2 9.5 for the last class. The number of pages as it is, no changes. 380 plus 100 plus 12 plus 6 and plus 2 and number of observations total 500 pages given in your question. It is exclusive, but this distribution convert to inclusive classes. Next heading write down inclusive classes. Okay, so inclusive frequency distribution. The same two column row, same line. Next heading also same number of error per page. And number of pages. Our frequency F. Our rules generally lower limit 0.5 less, upper limit 0.5. When inclusive, okay, inclusive classes convert to exclusive. So rules lower limit 0.5 less, upper limit 0.5. But here exclusive classes is given and convert to inclusive. So our rules is inverse. Lower limit 0.5 and upper limit 0.5 less. Minus 0.5 plus 0.5. Answer is 0. 1.5 minus 0.5. So 0 to 1. 1.5 plus 0.5, 2. 3.5 minus 0.5, so 3. 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. And last is total. Number of pages as it is write down 380, 100, 12, 6 and 2. N is equal to 5. So we have completed for the illustration number 12.